Hi everyone. In this video, we are going to start with the fourth algebraic identity, that is a plus b plus c whole square. This is actually a new identity for class 9th. And in this video also, like in the previous ones, we are going to do proof, expansion and factorization, right? So without wasting any time, let's quickly start with it. Okay, the identity says a plus b plus c whole square. So in order to do the proof, what we are going to do? We are going to multiply a plus b plus c along with another a plus b plus c, right? Whole square means that. So now over here, what do we have? We have got a trinomial multiplied with a trinomial, right? So that means we have to carefully multiply each term of your first bracket along with the each term of your second bracket, right? So let's do that. A into A gives us A cube. Then A into B gives us AB. Sorry, my bad. It gives us only A square, right? So A into C gives us AC, right? After that, B into A gives us BA. Then B into B gives us B square. And then last term for B into C giving us BC, right? Now, we are just left with one term, the last term from your first bracket. So, C into A gives us CA. Then, C into B gives us CB. And the last, C into C gives us C square, right? So, we had three terms here, three terms there, right? So, we have got the whole expression written over there, right? Now, what do? We first write all the square terms, that is a square plus b square plus c square, right? Now, I will collect the like terms. AB and BA, they are like because though the order differs, but that is in multiplication, they are still same. So upon adding them, I'll get 2AB, right? Now, I will do BC. It is BC and CB. That means they are also same. So I'll write 2BC. And lastly, we have AC and CA. So we'll write 2CA, right? That means we have collected all the like terms. And guys, this is a final identity. That means A plus B plus C whole square is actually equals to A square plus B square plus C square plus 2AB plus 2BC plus 2CA. It is so similar to your first identity of A plus B whole square because over there you had just two terms, right? So we had A square, B square and 2AB. Now, because of the addition of C, that is a third term, we get C square as a perfect square term, and then we get a combination of BC and AC also, right? So we got two extra terms of 2BC plus 2CA, right? And moreover, see how I have written the expansion. It is in a cyclic order. A, B, C. So first we get AB. Then continuing with B, we get BC. Continuing with C, we get CA. I suggest always maintain the order because it will help you to avoid any confusion whether you have actually used that term, used that product or not. Okay. So this was the proof. Now, that means what we are going to use always with respect to this identity is just this expansion. We don't need to do this proof every time. We have got three terms. We are supposed to do a square. You just use this expansion and you're good to go, right? Now, moving on with the first portion of expansion. The question says 2a plus 3b plus 4c whole square. So what are we supposed to do? Expand. Now, this is your first term, second term, and third term, right? So I'm writing the identity in terms of x, y, and z. If I had x plus y plus z whole square, it should be giving me x square plus y square plus z square plus 2xy plus 2yz plus 2zx. See, over here also, by default, I had a order xyz, right? Now, substituting the values, my x is 2a. So 2a whole square plus 3b whole square plus 4c whole square, right? These were the three square terms. Then the products. 2 times 2a into 3b plus, I'm writing underneath, 2 times 3b into 4c plus 2 times 4c into 2a, right? So what are we getting now? We have to just expand things over here, right? So what is 2a whole square? That is 4a square. 3b square gives us 9b square, and then 4c square gives us 16c square. After that, the products. So in the products, we get 2 into 2, 4, 4 into 3, 12. It becomes 12ab. Okay, guys, at this step, I have seen many children getting confused with the distributive property. They many times ask, ma'am, the 2 we have written outside needs to multiply with 2a and then with 3b also? No. If you have multiplied the outer 2 with 2a, that means it's done, it's used. You can't multiply that again with 3b, but you just multiply the product of 2 and 2a with 3b. Okay, so be careful. Then plus 2 into 3 is 6, 6 into 4 is 24. So we get 24 BC. Now the last product, 2 into 4, 8, 8 into 2 is 16. So we get 16 CA. And that is all. We have expanded. We don't have anything further to do in this question. And this is the final. We had all positive terms over here. We had all positive terms in the expansion. Okay. Now, since I have talked about the positive terms, right? Because this identity actually does not has any negative counterpart. In the sense, as you have a separate identity for a plus b whole square and a minus b whole square, this identity does not has anything with respect to like a minus b plus c whole square or a plus b minus c whole square, like that. We will be dealing with the questions here itself in this video only, where the terms will get negative and how we are going to actually use them in the expansions or factorization as well, right? So moving ahead with that, my next question is actually dealing with negative. So we have negative x plus 2y minus 3z square, whole square, right? So we are going to first write down the identity, which is a plus b plus c whole square equals, we have got a square plus b square plus c square plus 2ab plus 2bc, sorry, plus 2bc plus 2ca, right? Substituting the values now. So we get minus x whole square. Yes, when we have the identity of a minus b whole square, we do not substitute negatives over there because the identity is already dealing with a negative counterpart, which is a minus b whole square. But the identity over here is all with respect to positive terms. So if you have any negative in the given question, you have to plug in the negative value over there. Okay. So my first term was negative x. So I substituted negative x whole square. Then 2y whole square. And after that, negative 3z whole square. So these were the squares. Now moving on with the products. 2 into minus x into 2y, right? Then 2 into 2y into minus 3z plus 2 into minus 3z into minus x. I hope the substitution of negative terms is clear, right? So furthermore, moving on, what we get? What is minus x square? Just x square plus 4y square plus 9z square. These are the square terms. Moving on with the products. We have 2 into minus 1, minus 2. Minus 2 into 2 is minus 4. So we get minus 4xy. Now the second product, That is 2 into 2, 4. 4 into minus 3 is minus 12. Minus 12 yz. And the last product now, 2 into minus 3 is minus 6. Minus 6 into minus 1 is plus 6zx. This is the final answer for this expansion. We saw there were two negative terms. The squares were all going to be positive because squares can't be negative, right? But when we have products, we got two terms negative, two products negative, which had a single negative term initially. That means over here, the first product we have just A as negative. In the second, we had C as negative. But in the third product, we had A and C both negative, which actually turned my third product positive, right? So this is your final expansion. Now, the third question for expansion over here, we have half A minus 1/4 B plus 2 whole square. Over here, I have picked a portion where we have got rational coefficients. But the identity remains same, the application remains same. So let's do that. Now, I'm not writing the identity intentionally so that you learn to substitute it directly. What do we get? We get 1 by 2 A whole square plus minus 1 by 4 B whole square plus 2 square, right? Moving on with the products, 2 into 1 by 2 A into minus 1 by 4 B. Then plus 2 into minus 1 by 4 B into 2. And the last 2 into 2 into 1 by 2 A, right? Now the expansions, half A whole square gives you 1/4 A square, then 1/16 B square, and then 4, right? Okay, now dealing with the products. 2 and 2 gets cancelled. So what are we left with? We are left with minus 1/4 AB because we had A into minus 1/4 B. So that gives us minus 1/4 AB. The last, next product, second one. Now, 2 into 2, 4 and 4 got cancelled. So just left with minus B, right? Over here, 2 and 2 got cancelled, left with 2A. Guys, this is the final answer for this expansion. In all the three expansion questions, we saw that it had only two steps, where first we are substituting the values in the identity, and in the next when we are just simplifying, expanding terms. So be careful with the steps. Okay, this identity does not has much of variety, has very limited set of questions, but it is being used when you actually club with other identities also, and that we will see in later videos, right? Okay, now the next set of questions, which is factorization. Okay, whenever we do factorization, I always tell how to first identify which identity needs to be applied, right? I had told that for all the identities for first, second, third, right? Now over here also, how do we do it? What we are going to do, we can identify that there are three perfect squares, right? Your first two identities or even the third identity, none of them have any three perfect squares. So when you are having three perfect squares, it actually implies that we should be applying this identity, right? So let's see how do we start. 9x square, that means it is a square of 3x. So I write like this. Then 4y square means 2y whole square. After that, 16z square means 4z whole square. This is what we get. After that, it should be 2ab, right? Means we should be having 2 into 3x into 2y, right? All positive, right? 12xy positive. So we can verify 2 into 3 is 6, 6 into 2, 12. So we're getting 12xy. Seems correct, right? Moving on, we have plus 2 into 2y into 4z. Verifying now. 2 into 2, 4. 4 into 4, 16. Y, z. But this term is actually negative over here. Now, if the product is given negative in a factorization quotient, we have to understand whether it is going to be my y or z, which is negative. So how do we decide on that? We have to see, do we have any other term also negative? And yes, we do have, which is the last product minus 24xz. So what is common in both of them? We have got z as a common element. So whatever is common, it shows that that particular term is actually your negative component, right? So I will include now negative with 4z. I included that in the whole square term. I will include in your second product also. And proceeding with the third product, which gives me 2 into minus 4z into 3x. So let's verify for the third product. That is 2 into minus 4 is minus 8 and minus 8 into 3 is minus 24xz, right? I hope this negative factorization is clear. So what do we write now? We get 3x plus 2y minus 4z whole square, right? The final factors 3x plus 2y minus 4z into 3x plus 2y minus 4z. This is your final answer upon factorization using your fourth identity. That is a plus b plus c whole square, right? In this question, we learned the factorization along with the factorization of negative terms, right? Now, the next question. So what do we have over here? We have 2x square plus y square plus 8z square minus 2 root 2xy plus 4 root 2yz minus 8zx. Whenever you will have only a quotient belonging to this identity, guys, this kind of quotient is actually important because you will not find perfect squares over here. 2x square is not a perfect square. 8z square is not a perfect square because 8 and z are not perfect squares, right? So what we need to see over here, we need to see that how to figure out how to square root. Okay, I will tell you over here. What is 2? I can write 2 as a product of root 2 into root 2, right? That means 2 can be written as root 2 square, right? Similarly, talking about 8. What do we get 8? If I prime factorize, 8 is 2 into 2 into 2 because we want a square root. That is why I'm writing a root over there. What does it gives me? It gives me 2 root 2. So I can write equals 2 root 2 into 2 root 2 will be 8. That is 2 root 2 square. What I'm doing over here, I'm trying to explain that if you do not have a perfect square term for fourth identity, we can figure it out by either prime factorization or by breaking it with roots as well, right? So now we will actually apply the identity. Now what I will do, in place of 2x square, I will write root 2x whole square because this is going to give me 2x square. Then y is a simple term, just y whole square. And after that, 8z square means 2 root 2 z square. This is what we have, right? Okay. Then we have to talk about the products. So we get 2 into root 2x into 2 root 2. Sorry, it was supposed to be y. So we have y over here. Now, the quotient says minus 2 root 2xy. And then we have another term minus 8zx. Two negative terms. As I told in the previous question, you have to see which two products are negative and what is the common term in those two negative products. We can see we have x, right? That means your x term is actually negative, right? So moving on now with the products. Second product gives me 2 into y into 2 root 2 z. And last, 2 into 2z. 2 root 2 z into minus root 2 x. Okay, we haven't verified the products. Let's do that. 2 into minus root 2 is minus 2 root 2 into xy, which is correct, right? Second product, 2 into y, 2y, 2y into 2, 4y, 4y into root 2, 4 root 2y x, which is, sorry, it was z and it is also correct. And the last, 2 into 2, 4, 4 root 2 z minus root 2. So 4 root 2 into minus root 2 gives you minus 8 zx, and that is correct. Okay, so moving on. Minus root 2x plus y plus 2 root 2 z whole square. So writing the final factors, minus root 2x plus y plus 2 root 2z into minus root 2x plus y plus 2 root 2z, and that's all. Right? So guys, in this video, we did the identity of a plus b plus c whole square, right? We understood its proof, that how the expansion actually comes, and then we did quotients based on its expansions, followed by the quotients with respect to factorization. Along with that, we also understood that how to deal with negative terms in this identity where everything is just inclusive in it, right? So do practice these quotients, and if you have any doubts, you can always comment. Happy learning!